Hello, today I'm going to show you how to set up the USART peripheral to print messages to a serial console. This board has 4 USARTs supporting master, synchronous SPI, and modem control. Okay, I'm going to show you the code before I explain how to configure the USART peripheral in order to print messages to a serial console. I'm not going to explain the LED init and PV functions as they just configure the push button and the built-in LED. I think it's pretty basic and there is a lot of information on how to do it. But you'll find this code available on my GitHub page, so don't worry about it. Now, the important function in this code is the console init function. This is where the USART setup takes place. And here's the code, and I hope that it helps you. USART stands for Universal Synchronous Asynchronous Receiver Transmitter. It's a microchip that facilitates communication through a computer serial port using the RS-232 protocol. A USART is also known as a Serial Communication Interface, SCI. USART is similar to UART as each supports and provides serial communication. However, UARTs only support asynchronous serial communication. You can see in the following table the difference of USART and UART, but the main ones are that USART can work just as an UART, whereas UART cannot do its function like USART. USART is faster than UART, and USART is more complex than UART. As we can see in the following picture, the USART TX and USART RX ports are connected to PA2 and PA3 pins. This means that we can connect the virtual COM port to the USART2 pins on the MCU. We will implement a driver function called console init that initializes USART2 to work with the virtual COM port, so we will be able to print messages through serial port connection. First, in the clock configuration register, you need to clear the HCLK prescaler bits and set the division factor by 4. As a result of this, we will set the APV1 clock to 12 MHz. This has to be done in the clock configuration file that we created in the previous video. In the AHB peripheral clock enable register, you need to enable the GPOA clock by writing a 1 into the bit 17. The pins PA2 and PA3 have to be configured in alternate function mode. You only need to write a value of 2 in mother 3 and mother 2. I recommend you to always take advantage of the macros already defined within the STM32 libraries. As we saw at the beginning of the video, we need to select AF1 for PA2 and PA3 pins. First, clear the AF cell 3 and AF cell 2 bits, and then you can write a 1 on AF cell 3 and AF cell 2. In the APB peripheral clock enable register, you need to enable the USART2 clock by writing a 1 into the bit 17. You will need to clear the USART2 control register CR1, CR2, and CR3. In the clock configuration register 3, you need to select PCLK as the clock source for the USART2. And in the USART control register 1, we will select the oversampling by 8 option. When oversampling by 8 is used, the receiver engine takes 8 samples in a 1-bit period of 1-bit time, and the samples taken at the positions 4, 5, and 6 will be compared to understand whether this bit is 1 or 0. By using these sampled values, the USART understands whether it is valid data or noise. The following formulas can help you to understand how to calculate the baud rate register value. You just need to divide the clock rate by 8 times the baud rate. You will get the mantissa and the fraction. In this scenario, our mantissa is 13 and 1101 is its binary value. The fraction is rounded, and in this case, as it is considered as 0, our full value is equivalent to 208. This is the value that we need to write to the baud rate register. As we want to analyze the message sent through the USART peripheral with the logic analyzer and the maximum frequency of the one I currently have is 24 MHz, that's the reason that I configured the clock frequency at 12 MHz. In the USART control register 1, the transmitter and receiver bits must be enabled. And also you need to write a 1 into the bit 0 to indicate that the USART 2 is going to be enabled. These are the connections that I will be using to analyze the USART data. If you have a logic analyzer or an oscilloscope, you only need to connect the TX and ground pins to analyze the signal. Okay, I'm going to enter in the debug mode of the STM32 IDE, and let's wait until it is ready. Okay, I think that I placed the breakpoint on the line 46 just to stop the program in that line, and this is the way that you can create a console. This is the configuration that you need. Okay. The USART console is the one that I have connected right now. As you can see, it is working. And I think that I just need to press the play button. Okay. This program is the one that will show us the data. Okay. Great. Okay, cool. As you can see, here is our message. I always recommend you to analyze the data in this way, as you will understand exactly how the messages are being sent.